Hi, I'm Rakesh Umdi, HOD of Mathematics Department, Jain Polytechnic, Belagavi. In this session, we are going to study third unit of Engineering Mathematics 1, that is probability. In this chapter, I am going to cover introduction of probability, basics definitions, addition law of probability, multiplication law of probability, and conditional probability. Actually, what is probability? Probability is the measure of uncertainty of a various phenomenon numerically. It can have a positive value from 0 to 1. Probability of an event, it is denoted by P of A, that is equals to number of outcomes favorable to A divided by total number of possible outcomes. We can write this as probability of an event P of A is equals to n of A divided by n of S. Total number of favorable outcomes divided by total number of outcomes in the sample space. Next, random experiments. An experiment whose outcomes cannot be predicted in advance is called as a random experiment. For example, if I roll a dice, I will not be knowing that whether I am going to get 1, 2, 3, 4, 5, 6. I may get any number. Hence that becomes a random experiment, or else tossing a coin. If I toss a coin, then I may get heads or tails. First only I cannot predict. Sample space. The set of all possible outcomes of an experiment is called as a sample space of an experiment, and it is denoted by S. For example, I'll consider one experiment, rolling a dice. Now, what all possible outcomes are there if I roll a dice? That is 1, 2, 3, 4, 5, 6. These 6 outcomes I'll be having if I roll a dice. Event. A subset of sample space associated with a random experiment is called as event or case. For example, if I roll a dice, I will be having 6 options, 6 outcomes. That represents what? A sample space. Now I'll take one event, that is getting odd number. Then the set of outcomes which are favorable to this event is the subset of the sample space. Sample points. The outcomes of an experiment is called as a sample point. A certain or sure event. Sure event means definitely it happens. An event which must occur, whatever be the outcomes, is called as a certain or a sure event. Example, if I roll a dice, then I may get number from 1 to 6. Then definitely I am going to get a number that is a sure event. Impossible event. An event which cannot occur in a particular random experiment is called as a impossible event. For example, if I roll a dice, then what is the probability of getting 7 number? That is impossible event, because we have only 6 faces and 6 numbers on the dice. Elementary event. An event certaining only one sample point is called as an elementary event or indecomposable event. That is an event which has only one samples point, that is called as elementary event. Favorable event. Let S be the sample space associated with the random experiment, and let E is a event, is a subset of sample space, then the elementary event belongs to E are known as the favorable events to E. Example, If I roll a dice, I'll be having a sample space 1, 2, 3, 4, 5, 6. And I have one event E, that is getting even number. Means I'll be having the option 2, 4, 6. 2, 4, 6 are called as favorable events. Compound events. An event containing more than one sample point is called as a compound event or decomposable event. Addition law of probability. If A and B are any two events associated with an experiment, then P of A or B is equals to P of A plus P of B minus P of A and B. Eventually, P of A union B is equals to P of A plus P of B minus P of A intersection B. And if there are three events, P of A union B union C, then it is P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. Multiplication law of probability. P of A intersection B is equals to P of A into P of B. Conditional probability. Let A and B be the two events associated with a random experiment. Then the probability of occurrence of event A under the condition that B has already occurred and probability of B is not equal to 0 is called as the conditional probability. That is P of A bar B. Probability of A when B has occurred is equals to P of A intersection B divided by P of B. Suppose if it is P of B by A, then it will be probability of A intersection B divided by probability of A. And also we should remember one thing, that probability of A bar P plus probability of A bar P will be always 1. Now we'll understand the concepts using some examples. A dice is thrown once. Find the probability of getting first one a prime number, second one a number greater than 4. Now the sample space for one die is rolling is 1, 2, 3, 4, 5, 6. First one is a prime number. Let's take event E is equals to a prime number. Then event E is equals to, what are the prime numbers present in this? 2, 3, 5 are the prime numbers. Number of elements in the E is n of E is equal to 3. Therefore, probability of E is equals to n of E divided by n of S according to the definition. That is, n of E is 3 divided by n of S is, number of elements in this is 6. 3 divided by 6 is equals to 1 by 2. Now second one, a number greater than 4. Let's take this event as f. F is equal to a number greater than 4. Then f is equals to number greater than 4. We have only two choices, 5 and 6. N of f is equals to 2. Therefore probability of f is equals to n of f divided by n of s. That is 2 divided by number of outcomes in the sample space 6. 2 divided by 6 is equals to 1 divided by 3. We have one more example here. A pair of dice is thrown once. If the two numbers appearing on them are different, find the probability that the sum of number is 6. Now here we are rolling 2 dice. Therefore sample space will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, like this way up to 6, 6. That is, total number of outcomes in the sample space is 36. That is, n of s is equals to 36. Now E is a event, sum should be 6, provided one condition they are given, that they should be different numbers. So I'll be having the option 1 plus 5 is 6, both the numbers are different. 2 plus 4 is 6, both the numbers are different. 4 plus 2 is 6, 5 plus 1 is 6. I cannot take here 3 and 3 because both the numbers are same. Now, total outcomes in the event E, n of E is equals to 1, 2, 3, 4. We have 4. Probability of event E is equals to 4 divided by 36. Therefore, after simplification, we'll get 1 divided by 9. An integer chosen at random from the number ranging from 1 to 50. What is the probability the integer chosen is a multiple of 3 or 10? Now, our sample space is 1 to 50, all the numbers, because they are given. Total number of outcomes in the sample space, that is n of s, is equals to 50 numbers we have. Event E is multiple of 3 or 10. Multiple of 3 or 10, 3, 6, 9, 12, like this way, these are all multiple of 3 or 10, multiple of 3 between 1 to 50. Union, multiple of 10, 10, 20, 30, 40, 50. Now, if I combine these two, then I'll be having totally 20. As 30 is repeated twice, we have to consider it as only 1. So, we have total number of elements in the E is 20. Probability of E is equal to n of E divided by n of S, that is 20 divided by 25, that is 1 divided by 5. Now, here we have one more example. Two unbiased dice are thrown once. Find the probability of getting the sum of the numbers obtained on the two dice is neither a multiple of 2 nor a multiple of 4. Now, two dice I have rolled, therefore the sample space will be having 36 outcomes, that is n of s is equal to 36. E is multiple of 2 or 4. First we have to consider it as multiple of 2 or 4. E is equals to 1 1 is a multiple of 2, 1 3 multiple of 4, 1 5. Like this, if I have gone adding these, all will be the multiple of 2 or 4. Therefore n of E is equals to 18. The probability of E will be is equals to n of E divided by n of S, that is equals to 18 divided by 36, that is 1 by 2. This is the probability of getting a multiple 2 or 4, but we don't want the probability of getting 2 or 4. So we have to do one thing, that is probability of E bar, neither 2 nor 4. E is equals to 1 minus probability of E, that is 1 minus the probability of E is 1 by 2. 1 minus 1 by 2 is 1 by 2. Probability of getting neither multiple of 2 nor a multiple of 4 is 1 divided by 2. A family has two children. What is the probability that both are boys given that youngest is a boy? This is the example of conditional probability. Here we have the sample space. If a family is having two children, then it may be boy boy, boy girl, girl boy, or both may be girl. Total number of outcomes in the sample space n of s is equals to 4. 1, 2, 3, 4. 4 options we are having. Let E be an event, both are boys. E is equals to both are boys, BB, only one event. Let F be an event, youngest is a boy. Youngest means second one should be a boy, BB, GB. We can take these two. Now, probability of E intersection F is, the common thing in both the sets is BB, BB. So, BB is the E intersection F. That is only one term divided by total number of outcomes in the sample space, 1 divided by 4. Now, probability of E bar F. probability of E when already F has occurred is P of E intersection F divided by P of F is equals to, this is 1 by 4 and the probability of F is 2 divided by 4, that is 1 divided by 2. If I simplify this, I'll get 1 divided by 2. Hi, I am Rakesh Umadi, HOD of Mathematics Department, Jain Polytechnic, Belgavi. In this video, I'll be discussing the second part of Unit 3, that is logarithms. In this, I am going to cover laws of logarithms and some examples. Here we have laws of logarithms. Log m plus n is equals to log m plus log n. Log m minus n is equals to log m divided by log n. Log m raised to n is equals to n into log m. Log m to the base n is equals to log m to the base a divided by log n to the base a. These are the 4 laws of logarithms, and these 2 are the properties of logarithm. Log of 1 to any base is always 0. Logarithm of 1 to any base is always 0. Logarithm of any number to the same base is always unity. Logarithm of any number to the same base is always 1. Let's understand this using some examples. Here we have an example. Prove that log 2 to the base 4 plus log 2 to the base 8 plus log 2 to the base 16 is equal to 13 divided by 12. Now we will apply here change of base rule, that is fourth law. Log 2 divided by log 4 plus log 2 divided by log 8 plus log 2 divided by log 16. Later we can write this as log 2 divided by log 2 square is 4. Log 2 divided by log 2 cube is 8 plus log 2 divided by log 2 raised to 4 is 16. Now according to the third law, we can take this power as coefficient. So we can write it as log 2 divided by 2 log 2 plus log 2 divided by 3 log 2 plus log 2 divided by 4 log 2. Now we can cancel log 2, 1 by 2 will remain, plus log 2 get cancels, 1 by 3 plus again log 2 will get cancelled, 1 divided by 4. If I add these 3 fractions, I'll get 13 divided by 12. Second example, log x cube to the base y into log y raised to 4 to the base z into log z raised to 5 to the base x is equals to 6. We have to prove. We'll take LHS. We'll apply change of base rule. Log x cube divided by log y into log y raised to 4 divided by log z into log z raised to 5 divided by log x. We can take this power as coefficient, 3 log x divided by log y into 4 log y divided by log z, 5 log z divided by log x. Log y will get cancelled, log z, log x will get cancelled, 3 4s are 12, 12 5s are 60 is the answer. Show that 2 log 16 divided by 15 plus log 25 divided by 24 minus log 32 divided by 27 is equal to 0. Now we have to take the LHS part and we have to prove RHS. Now this is the coefficient, we can take it as power, log 16 divided by 15 whole bracket square plus log 25 by 24 as it is minus log 32 divided by 27 as it is. Log of square can be written as 16 upon 15 into 16 upon 15. Now according to log m plus log n, we can take log m into n. We can multiply these two quantities. 16 divided by 15 into 16 divided by 15 into 25 divided by 24. As it is having minus, log m minus log n is log m divided by n. So I'll take multiplication sign and I'll take the reciprocal of this so that it will become division. If I Simplify this everything. I'll get 1. Everything will be get cancelled. I'll be having only 1. Log 1 is 0 according to the property number 1. We have one more example here. Prove that 1 upon log ABC to the base A plus 1 upon log ABC to the base B plus 1 upon log ABC to the base C is equals to 1. Now we'll take the LHS part and we'll apply change of base rule. 1 divided by log ABC upon log A plus 1 divided by log ABC upon log B plus 1 divided by log ABC upon log C. If I take this up, if take the reciprocal of this, then it will become log A divided by log ABC plus log B divided by log ABC plus log C divided by log ABC. Everywhere the LCM is same, the denominator is same, so the LCM will be same, log ABC. Then we'll be having log A plus log B plus log C. We know that log M plus log N into log O will be log MNO. Therefore, log A plus log B plus log C can be written as log ABC. If we cancel log ABC, then we'll get 1. If log A plus B divided by 3 is equals to 1 by 2 log A plus log B, show that A square plus B square is equals to 7AB. Proof. We'll take LHS part. Now take this denominator to the side, it will become multiplication. 2 log A plus B divided by 3 is equals to log A plus log B can be written as log AB. Now we can take this power as, coefficient as power. Log of A plus B divided by 3 whole bracket square is equals to log AB. If we cancel both side log, we will get A plus B whole bracket square divided by 3 square is 9 is equal to AB. Shift this 9 this side. A plus B whole bracket square is equals to 9AB. Expand this using the formula A plus B whole bracket square. A square plus B square plus 2AB is equals to 9AB. A square plus B square is equal to, shift this plus 2AB this side, it will become minus 2AB. A square plus B square is equal to 9AB minus 2AB is 7AB. This is the